Hello, this is my walkthrough video for Sprint 5. So for this Sprint, I decided that I would go with the game framework Sprint, and so I decided to make a game using Godot. Um, so early on, I found a series on YouTube that walked through the basics, but also had a lot of um, sprites and stuff. So you can see like their ships and lasers and there's a bunch of stuff. So I decided to use that as my goal, which is a little different from I originally planned, just because I tried making stuff. I tried making my own sprites, and it didn't very well. And I didn't want to spend a whole lot of time working on that. I wanted to focus on the game. So I followed that. So I made basically a little Space Invaders game, but just with meteors. So using Godot, everything is basically done through scenes. So the first scene that I created was the player scene. Um, and within scenes, you have different nodes. So we have the player node, and it has a bunch of children nodes. So like the sprite 2D is where I added in the ship sprite. The collision is what allows it to interact with the world around it. So this is one called polygon, so you can draw on different collisions. Um, laser position start is just a child node that allows me to mark where I want the laser to emit from. So a marker 2D. There's a timer. This just restricts the user from spamming um, laser, and then there's two sound effects. So there's a sound that happens when the laser is shot, and then one when the ship is hit. Um, so after that, I I also have a meteor class. It doesn't look like much right now because of it's pretty abstracted, but it has a sprite and a shape. Since meteors are pretty much all circulars, I just circle. Um, So one thing too that I could point out right now is there's collision layers and masks, and so these are the layers that these scenes can interact with. So inside of nodes, there's these things called signals. So one that I use for the meteor is on area entered. So when something enters into this collision shape, it will emit a signal. So I can tap into that signal using one of these. Um, but using the collision layers and masks, I can set what what scenes can see each other. So right now, like it is on layer 2, which I've named the meteor layer. Layer 1 is like the player, and each one is its own specific layer. And the mask is what it can interact with. So meteors can see the players as well as lasers. The meteor needs to know if it's hitting a player or if it's hitting a laser. Depending on those two, it needs to interact in a specific way. Then there's the laser scene. This one's pretty simple too, just like the meteor, pretty much. You got a collision shape sprite, just so that you see it and it can interact with the game. The UI is the general outlook of the game while you play. So the biggest things here are this label, which is essentially the player score, as well as this margin container, which you can't see anything right now, but it holds the lives, which are just little icons of the user ship. And so those are updated through code. And then there's the score timer, which ticks every second, which adds to the score. Game over is just the game over screen. So it does use a little bit of code to update the score. And it also just has a press spacebar to start again. The biggest scene, most complicated one, is the level. So the level inherits a lot of these other scenes. So you can see in here I have a player, I have meteors, I have lasers, I have a UI, and then the UI tags it screen. But so you can have child nodes, and this little icon right here shows that it's, and you can click on that to go over. Meteors doesn't technically have anything right now because the code generates meteor scenes as a child of this node. And then you can see there's some more audios here just for like stuff. So that's the main layout of my scenes. Following that, what you got to look at next is the scripts. So the scripts are what really make the game happen. So within Godot, you can use a variety of languages. I just opted to use the built-in one because I thought it was interesting and I wanted to learn it, and it was complicated. It's called GD script. It looks, as you can tell, a lot like Python. So it was fun to mess around with it. There's a few interesting things that differ, like right here for health, I can put a colon and then I can declare a type, and that hard fixes that variable to that kind of value. So you can see it up here too. This colon is declaring that meteor scene will always be of a variable type packed scene, and then I can load in scenes. We'll start with probably a simpler script. So laser is pretty simple. They all extend their parent node. So if we go to laser, see that it extends from that. This is something I don't really use a whole lot, but export var speed, the at export means that I can interact with it over here in the inspector tool. So if I wanted like instant just abilities to create and modify and change things, I could use export and have it pop up in here. So it does have two basic functions in pretty much every script, depending on how you set it up. A ready, which is done just when the node is created or initiated, and then process, which as it says is elapsed. It runs every time a frame occurs. So for the laser, I just create a tween. This is a specific data type that allows an easy scalable factor. So I use it for I do tween property to get the method. And then this $sign specifies a node over in the scene viewer. So you could do stuff by like over. But this grabs that sprite 2D and it grabs the factor scale on it. And vector 2 is essentially how I'm changing it. And then from vector 2 is also how I'm scaling it. So how I'm doing this is I'm starting with a vector 2 of 1, 1, which is the regular size, and then 0.2, and then dot from is saying from this vector, scale to this vector at that rate. So it goes from non-existent to its regular size with a scale of 0.2. And then for the process, I need to update the Y position every frame so it's moving. And you multiply, if you're dealing with positions or velocities or things like that, you usually multiply it by delta to make it consistent across screens. Otherwise, you'd have a different speed if you're on like 60 frame per second or a 30 frame per second monitor or computer. So that's laser. UI is pretty simple as well. We load in the player's life image and then time elapsed. This is another short way of declaring a specific value. Instead of this one doing a colon and then specifying an int by doing colon equals, it means it will be whatever this value. So it hard locks it to an integer. Set health is a function that I have created that I use, I think, over in the level scene. All this does is each time that it is called, it resets the children of the margin container. So essentially resets it to use 0 life by using q.free, which just deletes it. And then it loops over the health. It creates a new textured rectangle. It applies a new image, which we loaded up here. And this is just to make sure it displays correctly. This is just adding it as a tool. So that one is for updating the health amounts. On score timer, this is how we calculate the time. So this goes back to one of the signals over here with the timer. When you connect it, it brings it into this script. And so every second, this function gets triggered. And then we just do time elapsed plus 1, make that a string, and that's how we display it. And then we also have global over here in the file system. I have global and I have a global GD, which is just a script that any script can have access to, any scene can have access to. So I use it just to store the score so that any script could use it, because my game over screen, it needs to be able to use that. So you'll see here for game over screen, if we go to it, this, your score is hard coded in, and then I just take that hard coded value here and add on global score. And then this is the function to handle if the user presses space, then they get redirected to the level scene. That's those. The player scene has a few things. Again, I use that export. I didn't really use it. This is used again for the shoot again is used to aid in the timeout to make sure that the user doesn't spam everything. So this ready is how I am setting the player's position at the start of the game. So this just sets them in the very center of the screen. And the process, every frame it checks to see if one of these inputs is pressed, which I've customized just to say left, right, up to make it simpler. This uses velocity. Velocity is a built-in function, a built-in method that I can use instead of having to use delta. So it's used for often for players. You just take the direction, which I'm getting from here, and I multiply it by the speed, which is there. And then I use move and slide to apply that velocity to the player. And this is my logic behind allowing them to shoot. So if they have the action key for shoot pressed and shoot again is not, well, and shoot again is true, then we emit it, we set that flag equal to false, and then we have the timer, which starts, and that updates this as well. At the end of timer, it sets it equal to true, and then we reset it to false here, so it is in a constant loop of constantly back and forth. And then laser sound is just played. On laser timeout, this is the function that's associated with that timer. At the end of the timer, we just set it equal to true, like I was saying. And then on collision sound, play the collision sound. Meteor is more of the same, pretty much. This big if tree is basically how I'm getting the sprites. So I just have this folder here, which has a bunch of different meteor styles. So this is just big if tree where it generates random numbers, and depending on the number, it'll randomly select the image. Setting start position, this is how they're rotating. So this is pretty similar to the player. On area entered, this is another one that is used just with collision 2D so that it can detect when something is in it. This is the code that runs. This is basically freeing up the laser. This is freeing up the meteor, so it's just deleting them with the pit. And the last one, level. Again, it has a lot of the things that we've seen before. These are packed scenes. This is how it's loading in the meteors and the lasers. And that's how they get added into these two sub-children here. That's the starting health. This is using something called groups to allow me to interact with the UI scene really quickly. This is a timer that I use to create timer meteors every second. This goes more in depth on the collision. So if I get hit, if that collision signal is detected, you take 1 health, you call set health from the UI, which is this one right here. And if your health is equal to 0, there's a few things here that I do that helps redirect the page. And then on the laser, it is doing the same thing basically as it just allows me to spawn it in. So with all that, go into the game. A ship, we can move around. We have a laser that is kind of animated, has the sound effect. You can see when I hit a meteor, it deletes it. But if I get hit, my life goes down, you have that audio, and if I go all the way down, I get the game over sound and the game over screen. I can press space. I can play again. But yeah, that should pretty much cover everything. So a decent amount of code and a decent amount of managing the different nodes inside of each scene and dealing with area masks. And there's just a few things over in the inspector to edit work, but that should pretty much be it.